Okay, Joe, we will continue our discussion on conic sections. Today, we will look at the third case, which is the final case, that is b squared minus 4ac greater than 0. Okay, it's been a long lecture series kind of thing,
Yes,
right?
it's
Because we
been.
have looked carefully at each of those conditions, and we have found that each of those conditions give rise to different conic sections.
Yes.
The idea is that the how the y delta xy curve results conic in xy plane.
Okay. Yeah.
That is the main idea here. Okay, I will share my board. So, okay, Joe, can you see my board?
Yes, I can. Of
Okay, we
course.
will look now. Today we will look at the final case. But before that, I have to tell you something.
Mm.
In the previous class, you have criticized, or at least you have expressed your doubts about the proof that I gave after the class. You said that the proof was not purely algebraic; it involved geometric reasoning.
Yeah,
Remember
but
this proof?
yeah,
This proof. Okay.
yes,
You said it wasn't as good as elegant as this proof.
yes, the first one.
You know,
Hello.
I don't know if it's a justification or not, but Joe, can you hear me?
Yeah, yes, I can.
Okay, I don't know if it is a justification or not. I'm not trying to justify anything, but are we studying algebra, Joe?
No, we are studying algebraic geometry, so
Oh, okay. So geometric reasoning is allowed here.
all right.
Okay, there is a very important slogan in algebraic geometry. Uh, Slogan. This is a very important slogan. Every algebraic geometer must by heart this slogan. Every It's very important. Every algebraic geometer must uh, by heart this slogan. The slogan is think geometrically, prove algebraically.
Algebraic. Okay. Yeah, that's a nice slogan.
Okay, this is the slogan in algebraic geometry.
All right.
Slogan for algebraic geometry. This, I think, this was said by famous algebraic geometer John Tate.
John Tate. Haven't heard of him.
Okay. Okay. Now, so that's why geometric reasoning and geometric thinking is allowed.
All
But
right.
even you have to ultimately write proof in algebraic. Okay, that's what I believe. And I
Yes.
also believe that algebra is much more superior to geometry because of its ability to reveal deeper structures. Okay.
Okay.
Okay. Anyway, we will continue our discussion. Today we will discuss the third case. Case 3. Case 3. Case 3 is b squared minus
For
4ac.
AC greater than 0.
Okay. Okay. Here, since b squared minus 4ac is greater than 0, the y delta xy curve will have three possibilities, right?
Yes.
It can be like this. It can be because since b squared minus 4ac is positive number,
Yeah, it will be up on top of the x-axis.
no, 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 not just top,
Yeah, it will curve upwards.
upwards, upwards. Okay, this is delta x of y. This is y, or this
It will just
is this
touch.
can touch, just touch.
Yeah, touch at
In
one point on the
this case, there is only one root.
root. Yeah.
Okay, or it can have two roots.
Yeah.
Okay, since we know that delta xy is a quadratic equation, quadratic polynomial. Remember, b square
Yes.
minus 4ac
4a.
times y squared plus I think it is 2bd minus 4ae times
AEY.
y plus d square minus 4h.
4h.
I think this is it. Just let's confirm. Okay, b square minus 4ac times y squared plus 2bd minus 4a times y plus d square minus 4h. Okay, the condition is that it should be greater than or equal to 0. Okay. Okay, in this case, here,
Case.
Joe, in the first case meaning first subcase of case 3. Okay.
Yeah.
In this case, can you tell me the range of y for which delta x of y is greater than 0? Greater than or equal to 0?
Yeah, for all values of y, delta x y should be greater than 0.
Yes, exactly. Since it never even touches
Never the 0. Yeah, everything delta xy will be positive every time.
Okay. In this case, delta x of y is greater than 0 for all y for all real numbers.
For all y in real numbers, yes.
Okay. Here the conic formed is a hyperbola.
Oh yeah.
Hyperbola opening along the x-axis.
Okay.
Okay, I will give the proof, but let's write statements. Okay, I'll write this case finally because that's a very interesting case. Okay, here in this case,
It's a peculiar one.
Delta x of y is greater than or equal to 0 when if this is alpha and if this is beta.
So when y is less than alpha and y is
Less
greater
than or
than
equal to alpha.
alpha or greater than
Y can be equal to alpha since delta
yes,
xy is equal to 0 there.
0. Yeah.
Okay,
So less than or equal to alpha or greater than and equal to beta.
Y is greater than or equal to beta.
Beta.
Okay.
Okay.
Here the conic formed is again a hyperbola.
Okay.
Opening along Joe.
Y-axis.
Yes, opening along y-axis. Y-axis. Okay.
Okay.
In this case, this is a very interesting situation.
Okay.
In this case, can you tell me the values of y for which delta x of y is greater than or equal to 0?
Almost every point.
Exactly. In this case, delta xy is greater than 0 for all y for all real numbers, but here delta xy becomes 0 at a particular point.
At particular point, yeah.
But here delta x of y equal to 0
at y0 or something like
at
that.
okay at
y0
equal to y0,
y0.
where y0 is an arbitrary number.
And we can just name it in the graph.
Or you can say that you can also say that the quadratic equation has one root.
Yeah. Yeah.
Okay.
Okay. Yeah.
Or uh,
Delta x.
we can also say that the
Quadratic equation has one root.
quadratic equation delta x of y equal to 0 has only one
Root.
one solution or root.
Oh,
Okay. Solution.
okay.
And that solution we name it as y
Plus
naught,
y0.
y0. Okay.
Okay.
Now let's get into giving the proof. Let's let's discuss the first case. Okay.
Okay.
Proofs are the most interesting thing in our lectures. Okay. Proof for this case. Here, Joe, since delta x of y is greater than 0 for all values of y. Okay, let me ask you something. How can we proceed a proof here?
We can say that for all.
Because there is no there is no there is nothing to work here, because this is true for all cases.
All cases, yeah.
So that's why I just this proof is like a rabbit out of hat kind of proof, like a proof out of thin air kind of proof. Okay, since this is true for all real numbers, we are assuming a statement that is also true for all real numbers.
Okay.
Okay, that is, we are assuming since y square is greater than 0.
Okay.
Greater than or equal to 0 for all y element of R.
Okay.
Huh?
Okay.
We can since delta x of y is greater than
0 for all y element of R, we can say
we are also assuming a statement.
Okay.
A statement obey not obey. How can I put it? We are also assuming statement that is true for all y element of R.
Okay.
Okay. That statement is y squared is greater than or equal to 0. This is true for all y. Okay.
Yeah. Yeah. Since y is element of R, we can say that its square will always be a positive number.
Positive number. Okay.
Yeah.
And for any non-zero number, non-zero number b,
okay,
we can also write y squared over
b
squared
squared
will be
greater than 0, greater than or equal to 0.
Okay. Now let me add 1 on both sides.
Okay.
Y squared over b squared plus 1 will always plus 1 will always be greater than
plus 1.
Plus 1. And 1 is again greater
than 0.
0 exactly. So we can write, since inequality is a transitive relation, we can write y squared over b squared plus 1 greater than 0.
Okay.
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 Meaning this number,
okay,
number is non-negative.
Yes. So we can take the square root.
Exactly. We can proceed as the previous proof.
Okay.
Okay. So we can take the square root.
Square root.
Mm, that is square root of y
Y
squared over
squared over
b
b
squared
squared
plus 1.
plus 1 will always be
And
greater.
I'm naming it as x over a, plus or minus x over a.
Okay.
Okay.
Will always be greater than 0. Greater than 0.
There is the inequality is actually gone, Joe. We are
Oh,
just
okay.
okay.
All right.
This
All
is
right.
this y square over b square
Okay.
plus 1 is greater than 0. That is
Oh,
why
we are
we
just
took it square root.
okay.
Okay.
Understood.
Because we are working with real numbers.
All right.
Okay. So if it was not greater than 0, we cannot take the square root
Square root.
because that will
Yeah.
result in an imaginary number.
Okay.
Okay. And
All right.
I have named that real number as the roots, which are real roots as
X over.
plus positive x over a and minus negative x over a.
All right. Yeah.
Okay.
So if you take the squares, you will get
Okay. Taking squaring
square
on both sides. Squaring on
both
both
sides
sides will give us y square over b squared
plus
plus
1
1 equals x
is
over a, x square over a square.
a square. Yeah, we got the answer.
That is x squared over a
Over
square
a squared minus
minus
y squared over b squared will be equal to 1.
1.
All right.
This is the equation of hyperbola opening along x-axis because x the term with the x square is positive. The
Yeah.
term with the y square is negative.
Negative.
So this is a hyperbola opening along the
Opening
x-axis.
along
It
x-axis.
will look like this.
Yes.
Okay.
Okay.
Hyperbola.
Opening along x-axis.
Okay, exactly. Okay, Joe, are you satisfied with the proof?
Yeah, it's pretty straightforward actually.
Okay,
Once you understand the square root, understand this, it's actually the reasoning is sound.
okay,
It
but if you look at the proof for ellipse, we can see that we have finally got a ellipse centered at HK.
HK, yeah.
Here we have got a hyperbola centered at the origin.
Origin, yeah. We
Okay, there
can
is no h
actually
and k. We can actually make it a hyperbola centered at HK if we take instead of y squared greater than or equal to 0, if we take y minus k whole
greater
square is
than
greater than, which is
greater
still true.
than
Okay.
yeah.
And finally, we can name it this term as x minus
X
h over a,
H over A. Yeah.
similar to the proof for ellipse.
Ellipse, yeah.
Okay, that will because I haven't gone that way because I don't want it to be confusing.
Confusing. Okay.
Because this proof is already a bit bit like a proof out of thin air where okay, because this condition was like a universal condition type of thing.
Yeah, it's always a
Okay, this y squared is greater than equal to 0. Okay, so let's move on to our next proof. I will just okay, wait. Okay, let's put it in a box. This case proof is completely algebraic and is very tedious. So let's discuss it last.
at
Let's
last. Okay.
move on to the third case.
All right.
Here, the proof here is actually similar to this proof
Proof.
for the proof of ellipse.
Ellipse. Okay.
Okay. So for what values of y are delta x of y greater than or equal to 0, Joe?
For y less than or equal to alpha or y greater than or equal to beta.
Okay, let me draw this again here. Okay, let me name, this is alpha. Okay, this is beta. And let me name the center point alpha plus beta by 2.
Over 2.
So this is, let this be k.
Yeah, okay.
And the distance from alpha to that center is, we take it as b.
Okay.
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 So we can write k minus b equals alpha.
All right.
And
K plus b is equal to
k plus b equals beta.
beta. Okay.
So minus b equals
Alpha plus.
no. What is the condition here? Y is less than or equal to alpha. So y should be less than or equals k minus b.
K minus b, and y should be greater than or equal to k plus b.
Okay.
So y should be in the middle.
No. Let's solve these two inequalities and find minus b and plus b here.
Okay.
So y minus k will be less than or equal to minus b.
Minus b. Okay.
And
y minus k will be greater than or equal to b.
Okay. Meaning if this term here is b, this term, if this is minus b and this is b, y minus k will be here.
Yes.
Here and here.
And here, yeah.
Y minus k will be here and here. This is 0.
Okay.
Okay. This shows that my absolute value of b squared will always be less than or equal to absolute value of y minus k.
Minus k, yeah.
Or just b squared. Okay. Or just b squared will always be less than or equal to y minus k squared.
Y minus k squared, yes.
Okay.
Okay.
So did you have any doubt there?
No. I am.
Okay, you can just first of all you can just write absolute value of b is always less than absolute value of y minus k.
No, there is no need
Then
for
we
that.
can square it. Okay.
Yeah, then we can square it. Yeah.
Because
but I think the other one is much more intuitive. Yeah, straightforward. If you score that, if you pair it with that figure there, I think it is self-evident that y minus
the idea is very simple because absolute values are always positive.
Yeah.
Okay. If an inequality involves two positive numbers, like 2, if 2 is less than 3, 2 square will always be less than
3 square. Yes.
So we can write here absolute value of b square will be always less than or equal to absolute value of y minus k whole square.
Okay.
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 So if you divide throughout
By
LHS and RHS by over by b squared, we get 1 will be less than or equal to y minus
b k the whole square over b square.
Okay. If we move 1 to the right, we get 0. 0 will be less than or
equal to y minus k the whole square over b squared minus 1.
Okay, this shows that this number is a positive number.
Okay.
This is non-negative.
Non-negative.
Not positive. It can also be 0.
Yeah.
So this is non-negative.
No, negative. Okay.
Therefore, we can take its
square root.
Okay.
Okay.
Naming the square root as
X over x minus h over
yes,
x minus
as
h over a.
x minus yes, exactly, x minus h over a plus or minus two square roots.
Okay.
Square root of y minus k whole squared over
B
b
squared
squared
minus 1.
upon squaring
You'll get y minus k squared over b squared. B is equal to x minus 1 is equal to.
Joe, should I improve my handwriting? Am I writing too quickly?
No, it's all right
Okay, I
for
will just
me.
write neatly. Okay, squaring equals when we square here we get y minus k whole squared over b squared minus 1, and when rearranging we get y minus k whole
The whole
squared
squared minus b over b squared minus x minus h the whole over a squared equal to 1. Hyperbola opening along y-axis, I think.
exactly, and centered at hk.
And centered at hk. Okay.
This is hyperbola opening along the y-axis and centered.
centered at hk.
Okay, so this will look like this.
Yes.
And this point is h comma k.
Okay.
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 This
Let me
proof
ask
is
you.
somewhat similar to our proof of ellipse. Okay, Joe.
Of ellipse. Yeah.
Okay, Joe.
So are we calling the hk as the center itself? Is there any other name or for? It should be something like for.
No, no, no,
No.
no, no. Yeah, focus has another relation.
Another relation. Yeah, I remember.
Okay.
Okay.
Okay. So let me put this also in a box. I am trying to remember what was the equation for focus of hyperbola. I can't quite remember it now. I will look it up and I will tell you. Okay, now we will move on to the very interesting case here. In this case, the delta x of y is always greater than or equal to 0 for all values of r, for all values of y, but it becomes 0 at a single point.
Yes.
Meaning the equation delta x of y, meaning the equation
Delta
quadratic
x.
equation delta x of y equal to 0 has only one solution.
One solution, yes.
And solution is y naught. In this case, here the conic formed will be very interesting. Two crossing lines. Exactly, two crossing lines. Or a pair of straight lines, or a pair of straight lines intersecting at a single point.
Okay.
Okay. This will be like this. Pair of straight lines intersecting at a single point. Okay. This is a conic section.
Okay.
But we are not usually familiar with such conic sections.
Conic section, yes.
We are only familiar with the parabola, hyperbola, and the ellipse. And circle is also an ellipse.
Yes.
Okay. But if you remember, in the previous lectures, we have seen that here the conic section, I have written here that the conic section will be a single point.
Yes.
Can you say how a plane cuts a cone at a single point?
at its tip, if you want.
At the center.
Yeah, it's
For
like
instance, if this is a cone.
that is two cones, isn't it?
Okay, this is two cones. If the plane
If a plane cuts it horizontally at the tip, you will get a
at the
single
tip,
point.
okay, here the cone and the plane meets at a single point.
Yeah.
That is the condition here.
Yes.
Okay. What about crossing lines?
When it cuts vertically through the middle.
Exactly. Let me make it a cone here. This crossing line into a cone, into two cones. Okay.
Okay.
Uh,
I think you are stuck here.
so can you hear me?
Yeah, I can hear you now. Now it's
Okay.
all right.
Okay. Let this be two cones. Okay. If a plane just slices through like this, okay,
Okay.
slices through like this, it is actually hard to visualize it in actually
Yeah.
draw. This diagram is a 3. If you have to see it in a 3D.
Yeah, I understood. If it's it's like an hourglass, we have
Cut
cut
it through the middle,
cut it through the middle vertically, like this.
vertically, exactly. So that intersection of plane and cone will be two crossing lines.
Crossing line, yes.
So that is the case here.
Okay.
Meaning, straight lines are also conic sections. That is the idea.
Okay, all straight
Okay.
lines.
Meaning pair
Pero
of straight lines,
intersecting straight
a
lines, isn't
line
it?
intersecting straight lines,
Ah,
pair of straight lines. Actually, pair of intersecting.
straight lines are always straight lines. I recommend section.
Straight lines are also conic sections. Are also
Conic sections.
conic sections. Okay.
Okay.
Okay, but how about okay? Think about this. We know that conic sections are all solution sets of second degree quadratic equation two variable. Okay.
Two variables. Yes.
But straight lines are all not quadratic equations.
But
Linear.
actually, when I think about it, straight lines, there are two ways of, in my opinion, there are two ways in which the values can be, we can reconcile with this. One is if you, since here we have a solution at y is equal to y0, isn't it? At y0, delta xy is actually 0. B square minus 4ac term will become 0 actually, isn't it? I think like that.
B square minus B square minus 4 is
No.
delta x of y becomes 0.
Delta x of y equals 0. Suppose the equation is something like the delta. So suppose we write the whole equation like delta x of y minus a the whole square is equal to 0, something like that. Then delta x of y is equal to a, isn't it?
I see a
Since it has
point.
since it
Okay.
has only one root, whenever the quadratic equation has one root, it is a perfect square. So perfect squares
Yes.
can be
Okay.
written as
Exactly.
perfect squares can be written as x minus a the whole square is equal to 0. So
Joe,
here in that case
Joe, you have
delta
cracked my proof. That is exactly what I'm going to write today.
okay.
Okay. That's a very impressive to have predicted what I'm going to write. Okay. Let's look at the proof. Okay, and see more evidently the idea.
Okay.
Okay. Here we know that delta x of y becomes 0 at a single point.
Yes.
Okay, to find that point, let's first solve this quadratic equation. Okay,
We can
first,
solve this.
okay, first solving delta x of y equal to 0. I am not sure I will not be able to write it in this congested space. This is a very
So we can just
okay. I'll arrow mark here and write it down there. Okay.
yeah.
Okay. Proof here. First, let's solve the equation.
Okay.
First, let's solve delta x of y equals 0. Your idea is you are on that you are correct. Essentially, you are correct, but we have to make it more clear. Okay. Uh, so what is delta x of y? Delta x of y is b squared minus 4ac. Okay, Joe, solve it.
Yeah,
I'm too lazy. Okay, b squared minus
okay, let's
4ac
look at minus 4ac times y plus
y squared
oh plus y squared plus y into what was the equation 4a
2bd minus 4a
2bd minus 4ae
times y
plus times y
plus b
times
squared minus 4h
4h is equal to 0.
0.
So if you want, let's do okay. It's not
Let's
done.
use the quadratic formula. Okay, y
Yeah. Okay.
equals minus
Y is equal to minus of 2bd minus 4ae plus or minus root of 2 2bd minus 4ae the whole squared minus 4 into d square minus 4ah into b square minus 4ac the whole divided by 2 times b square minus 4ac.
2 times b squared minus 4ac. Okay, since this has only how many roots?
One root.
This has only one root. What must vanish?
The quadratic term was the term in the square
Discriminant.
root
The
is,
discriminant
should vanish.
must vanish. Okay, so we get two equations. So we get essentially two equations. Let me write them. So
No,
we get
so we get only one
two.
equation, isn't it?
No, we get two equations. Let me write. So we get two equations. The first equation is the discriminant equals 0. 2bd minus 4a whole square minus 4 times b squared minus 4ac times d squared minus 4ah equals 0.
Yes.
This is an equation.
Yes.
Okay.
Okay.
Any doubts,
Okay.
Joe?
No, if the discriminant must vanish means that the we will be left with only one y
That
is equal.
vanishing of the discriminant is an equation.
Yes.
The
Okay. Okay. Okay.
okay. Let me name it equation 1.
Okay.
Okay, and we have y equals what? Y equals
Oh. Okay. Okay. y equals 2bd minus 4ae
minus
divided
2bd minus 4ae divided by
by 2 times b square minus 4a
exactly 2 times
or
b
ac.
squared minus 4ac. This y is actually y naught, the solution.
Yes.
Okay. This is equation number 2. The vanishing of the discriminant is also an equation. That equation is a very important thing.
Okay.
Here. Okay. In fact, that equation is the most crucial here. We usually forget about that thing. Okay. We just make it, okay, this is 0. Now let's consider the root. But here that equation is very important. How you wrote it, Joe?
Yes, I am writing it. Yeah, I have finished.
Okay. From this equation 1, find the value of d squared minus 4h. From
Okay.
From 1, we can find d squared minus 4ah equals, find d squared minus
This
4h.
4ah should be equal to yeah 2bd minus 4ae the whole squared divided by b square minus 4ac.
Divided by b, 4 times,
4
4
times
times
4 times.
b squared minus 4ac.
Yeah.
Okay, this is the,
So
okay.
you can write, okay. Keep on
Okay,
going.
let me name this equation as equation 3.
Okay.
Okay, this form. This is actually equation number 1, but here we found the value of d squared minus 4ah.
Okay.
Okay, these are all constants.
Yes.
These are not variables. These will not change whether or not the x and y changes, because these are
Yes.
constant terms. Okay.
Okay.
Okay. Let's recap what we have done here. We have first took the equation of the discriminant of our second degree quadratic equation delta x of y, and we just made it equal to 0, since we know that it becomes 0 at y naught.
Okay.
Okay. Since it is equal to 0, and since it is a quadratic equation, for it to have a single root, its discriminant must vanish.
Must vanish. Yes.
Okay. So we are left with two equations. One is the equation one is the solution, and the other is the vanishing of that discriminant, this equation. From that, and that equation, the vanishing of the discriminant equation is fully compressed of constants. Okay.
Yes.
So
Yes.
that relation is like a kind of an identity here, because there is no variables here.
Okay.
We can use that relation anywhere.
Okay.
Okay. Okay.
Okay.
All of these terms are constants. Okay. Now what are we trying to prove? We are trying to prove that the conic section formed is a crossing line, isn't it?
Yes. Yes.
Okay. So what is the equation of the conic section? It is ax squared o plus bxy plus cy squared plus dx plus
This was ey
a b c d e y plus h equals 0. Okay, and we have converted this. This is the equation of conic. And we have converted this equation into minus b. Remember, plus or minus square root of delta x of y.
Yeah.
Or 2a.
Yes.
Remember, where a is still A. B is, if you remember, it is, I think it is by plus D.
Yes.
Let me go back and check, Joe.
Let me
It
also
is
go
written in
back.
the first page for what are B, A, and C, Joe. A is A, B is by plus D, and C equals,
C is equal to cy square minus ey plus h.
and that equation we made it into this equation, and b square minus this b square minus 4ac is actually our delta x of y.
Okay. Yeah.
That's how we started.
Yes.
So we can write again, we are going back to that idea. So by plus c, so we can write this as minus, okay, and let's not expand, let's just
Okay.
write it like this. Okay,
Okay.
let
Okay.
b be b. Okay, b b b, let b be b. Okay, let's not
Okay.
write b as by plus d.
1 second. I'm just uh, wrapping my head around it. Okay. So our equation for the condensation was ax square plus bxy plus c y square plus dx plus ey plus h is equal to 0, and we called on writing this in terms of the powers of x, we found that we can write it as ax square plus capital bx plus c is equal to 0. So from there we found that x value was equal to x value was equal to negative b plus or minus the root of delta xy, isn't it? Delta x of y divided by 2a. Yes.
This is
Yes.
the idea here.
Yes.
Okay? Ax square plus bxy is our original equation. We have made it into an equation in x.
Okay.
Okay, this is actually a rearranged form. This is not an equation in x. It's still an equation in x and y.
Okay.
Okay, but we rearranged it so that it looks like an equation in x, quadratic
Okay.
equation in x, and when we apply the quadratic formula, we can find x as minus b, where b is by plus d,
Okay.
plus or minus b squared minus 4ac, and that b squared minus 4ac was our delta x of y.
Okay. At y is equal
And
to y
since
is here.
this is how we started. Okay, since
Yes.
delta x and y x is real, we have the our main condition we obtained as b square minus 4ac greater than or equal to 0, delta
Yes.
x of y greater than 0, and that actually opened up a a can of worms that we are still dealing with.
Yes.
Okay, okay, it is very interesting, correct?
Yes.
Okay, now let's come back to this equation. Okay, let's expand it. Let's expand. Let's write delta x of y here.
Delta x
Minus
of y
b
will
plus
be.
what is delta x of y? Minus b squared minus 4ac times.
So then we should write b also, right, like that, isn't it?
No, just write b as b. Let
Okay.
b be b. That's what I said earlier.
Oh, okay. Okay. Okay.
Okay, b squared minus 4ac times y squared plus 2bd minus 4a times y plus d squared minus 4h over 2 times a. 2 times a. This is x actually. X equals. Okay.
1 second. Let me write it here also. So h will be negative b plus or minus b square minus 4ac over y multiplied by y squared plus 2bd 2bd minus 4ae, yes, 4ae times y plus d square minus 4s,
Okay.
4s, 4 raised to 1 over 2, all raised to 1 over 2, the whole divided by 2a, yes.
Okay, let's move 2a to the. Okay, let's write 2a there. Let's only focus on the discriminant.
Okay,
Okay, on the discriminant delta x of y.
okay.
And instead of writing d square minus 4h, we have actually found the value of d square minus 4h here for our case.
Okay, yeah.
Okay, so let's substitute here.
Okay.
Let's delta x of y becomes b squared minus 4ac times y squared plus 2bd minus 4ae times y plus what is the value of d square minus 4h?
And b
Okay,
square minus, yeah, I'm looking at it. 2bd minus 4ae the whole square minus 4 whole square divided by 4 b square minus 4a 4ac.
by 4 b squared minus 4ac.
Yes.
Okay, take b squared minus 4ac common from all these terms, all the three terms. B squared.
But there is d square minus 4ah there. Oh yeah, so sorry. Uh, how can we take
Multiply
okay.
denominator and denominator with the b squared minus
Okay,
4ac.
okay, 1 second. 2bd 2bd minus 4ae the whole y plus it will be 2bd minus 4ae divided by 4b square minus 4ac.
No, just take b squared minus 4ac. There are what,
Yes,
what are
yes. 1 second. I'm just
I think we are on different pages here.
yes, yes. We are. Let's look
I
at this.
said take b squared minus 4ac common
Okay,
from
okay,
these three terms.
okay, okay.
Okay, if we take b squared minus 4ac out of the first term, we are left with y squared.
Yes,
If we take b squared minus 4ac from the second term, we are left with 2bd minus 4a times y by b squared minus 4ac.
yes.
Okay,
Okay.
isn't it?
Yes.
Then if we take b squared minus 4ac from this third term, what are we left with?
1 second. Uh, 2bd minus 4ae divided by 4.
B square minus 4ac if we take common from the
Yeah.
numerator,
Oh,
we have to first multiply with
yeah. I found it. It should be squared. 4ac squared.
exactly b square 2bd minus 4ae over 4b squared minus 4ac squared.
Yes.
Okay, okay,
Okay. Okay.
okay. Let me put these terms as a single term times. Okay, and let me put 4 inside the bracket, inside the square, so that we can get 2 times b square minus 4ac whole square.
Okay.
Okay,
Okay. Okay.
okay, understood?
Yes.
And so since both numerator and denominator are squares, I can put it in a single bracket
Yes.
with only one square.
Oh, so you are essentially making it some kind of a square.
Exactly. Have you understood the steps?
Yeah.
Okay, what is it? This is a squared plus
B squared 2b
Okay,
No.
if I multiply here 2 and divide with the 2 here,
Yeah.
a square plus 2ab 2ab a times b. A is
Yeah.
y, b is
Y.
2bd minus 4a or 2b square minus 4ac. This is a perfect square.
Yes.
Just
All right.
take your time. Take your
Yeah, I'm getting there. Oh, there was a square. I forgot to mention square. Okay. 2bd minus 4a
Take your time, Joe.
divided
It's
by
okay.
2b square minus 4ac. Yeah, the whole square. Yes. So this will be b minus b plus or minus b square minus 4ac times y square plus 2 times y times 2bd minus 4ae divided by 2 times 2 times b square minus 4ac plus 2bd minus 4ae the whole divided by 2 times square minus 4ac the whole squared. Yes, I'm getting the hang
Don't
of it.
take all the time in the world.
No, I got it.
It took me months to complete this. It's okay. If it's taking too much, it's okay.
No, it's b plus or minus. Yeah, I got plus or minus. No, plus or minus. It will be b square minus 4ac into y minus. Oh, y plus, isn't it? Y plus
Yes, y plus
2bd minus 4ae the whole divided by 2 times b square minus 4ac the whole squared.
this is from equation. Let me write it here. This is from equation 1. Okay, equation 3 here.
Okay.
Okay, so we get b squared minus 4ac times y plus 2bd minus 4ae over 2 times b squared minus 4ac whole squared. Okay,
Okay.
so when taking the square root, so square root of delta x of y will look like square root of b squared minus 4ac times square root of, okay, let me write it neatly here. So delta x of y, square root of delta x of y will look like square root of b squared minus 4ac times y plus 2bd minus 4ae over 2 times b squared minus 4ac whole squared.
Divided by 2a.
Okay, well, I'm just writing the delta x of y term here.
Yeah.
Okay, so we can write it as,
You can take root of b square minus 4ac into y plus.
we can take b square minus 4ac.
4ac inside the root.
Why, Joe? Why can we take b square minus 4ac square root? What is the reason? Remember our condition, third condition. B square minus
Yeah,
4ac is
ac always greater than 0.
That is why we are allowed to take it out of the square root.
Yes.
Otherwise, this perfection of this complete square will not be possible.
Yes.
Completing the square. Okay, that is a algebraic reason here.
Okay.
Look how it connects, interconnects
Yeah.
between the proof. That is why we are able to take it out, so that we get this perfect square, and the square root of that perfect square will be just y plus 2bd minus 4ae minus 4a over 2 times b squared minus 4ac.
Minus 4ac.
Okay, this is delta xy. So our equation, let me name this equation as uh, I don't know, equation number 4 or something. Okay.
Okay.
So equation 4 becomes x equals minus b plus or minus square root of b squared minus 4ac times y plus 2bd minus 4ae over 2 times b squared minus 4ac.
Okay.
Okay, over 2a, or 2a. Okay,
Okay.
I will move the 2a to the left side. So 2ax equals minus b plus or minus this relation, this equation.
Okay.
Okay, Joe.
Yes.
Now let's write the term. Okay,
B.
no. Let's split. This is actually, this is not just one equation. These are two equations, plus or minus. Okay.
Yes.
So we will write down those two equations. 2ax equals minus b plus square root of b squared minus 4ac times, what's in b squared minus 4ac times b squared minus 4ac times y plus 2bd minus 4ae over 2 times b squared minus 4ac and 2ax equals minus b squared minus square root of
Okay.
times y plus 2bd minus 4ae by 2 times b squared minus 4ac. Okay, Joe.
Okay. So this will be the yeah. This will be somewhat of a equation of a line. Two equations.
Okay. We will convert it into equation of a line. Before that, so for that, we have to write the actual value of b here. We know that b equals by plus d.
Yes.
Okay. Therefore, we get 2ax equals minus by plus d. So minus by minus d plus square root of, and we will just distribute the square root of b square minus 4ac into the bracket. So we get
Okay.
square root of b square minus 4ac times y plus b square minus square times y plus 2bd minus 4ae by 2 times square root of b square minus 4ac.
Okay. So you are trying to write it in y is equal to mx plus c terms. Are you,
Exactly. I'm trying to take y out of common from this.
okay. Okay.
So
So
so so we get 2ax equals minus by minus d, and I will distribute minus b square minus square root of b square minus 4ac into the bracket. So I'll get minus square root of b square minus 4ac times 4ac times y minus
it
2bd.
should be plus or minus, isn't it? Oh, yeah. You are writing both equations. Okay. Okay. Okay.
Just
Yeah. Yeah.
split
Yeah.
both,
Yeah. Yeah. Yeah.
write
I'm
both
understood.
equations separately.
Yeah.
minus 4. Those two are the two equations.
Okay. Yeah.
Two straight lines, crossing straight lines. Okay. Now take y terms common. So we get 2ax minus 2ax equals minus b plus square root of b squared minus 4ac times y plus the constant terms 2b
Yeah. I'm getting. I'm getting. I'm getting. It's more
4a.
something like the quadratic equation, isn't it?
No. It's not
If
quadratic
you
equation. Just minus d. There is a d here, and the second equation will become 2ax equals minus b minus square root of b squared minus 4ac times y plus sorry, not plus, this is minus just let's avoid the brackets here, minus 2bd minus 4ae 2bd minus 4ae over 2 times square root of b squared minus 4ac minus d. And let me name this term minus b plus square root of b squared minus 4ac as L1, and this term minus b minus square root of b squared minus 4ac as L2, and this term 2bd minus 4ae by 2 times square root of b squared minus 4ac minus d as m1, and minus
okay.
2bd minus 4ae over 2 times square root of b squared minus 4ac minus d as m2. Okay, let uh, let me name these terms as L1, L2, and M2, M1, M2, so that our equations become 2ax equals L1y plus M1 and 2ax equals L2y plus M2. So take
Okay.
all the time in the world.
No, I'm there. L1 Y1 plus M1.
No, not y1. X and
L1
y are
Y.
the same.
Yeah.
Okay.
L1 Y plus M1 and
X
2AX is
and y
equal
just are the same here.
L2 Y2 plus M2.
L2y.
Yes.
L2y.
L2 Y. Yeah.
Okay.
Hmm.
These
Which
represents.
implies Y should be equal to.
No, just write the right like these represents the pair of straight lines.
Yeah.
The pair of straight lines. Okay.
Okay.
Passing through their point of intersection. Crossing through because I have write crossing lines.
Yes.
Crossing through their uh, crossing through their solution. Their
Hmm.
their solution. Their solution. And that solution can be found by solving this equation. Okay. And solution is surprisingly
Equal to the
or
solution
not
of Y.
surprisingly, the y coordinate
Y
of the solution is y0 actually.
Y series. Yeah.
Okay, I'm not trying to solve here. That's again becomes tedious. Let me give you a homework here. Okay,
No,
problem.
it's very simple. At y is equal to y0, delta xy is equal to 0, isn't it?
Solve this system. Okay, very interesting.
No, it's very simple actually. We can say I can solve it. I think I can try it now itself.
Okay, okay,
At
okay. We will try.
at at y is equal to y0, we can say that delta x of
No,
y.
just try solving these equations.
No, let me just try it. 1 second. Uh, yeah, delta.
Find the value of x from one
Uh,
term and substitute
one
it
second. 1 second. One
into
second.
the other.
At 1 second. At y is equal to y0, which is actually equal to 2BDE. 1 second. Uh, oh, you need. Oh, let me just. Okay. The crossing lines means the solution means both x and y will be the same for both the lines, isn't it?
That point of intersection will be
Will
same
be
for both. So
both
that's
the lines.
why. Okay, well, let's solve
Okay,
the equation
okay.
right
I
now.
have an idea. I have an idea. So we say that. Uh, so let's reason like this. Okay. At y is equal to okay, we know that from the first we know that the equation is x equal to negative capital B plus or minus delta x of y divided by 2a, isn't it?
Okay.
So we can write 2ax is equal to negative b plus or minus delta x y.
That's what
Oh,
those equations are actually these equations.
yeah, let's so at y is equal to y0, we have already found that value, that is that's what was that, 2bd minus 2bd minus 4ae divided by b square minus 4ac.
Okay, we have found
2,
the value of y naught.
yeah, 2b square minus
Okay, we have
4ac.
found the value of y naught. Exactly. That's right. You are correct.
Yeah,
We have found
2b
the
square,
value of y naught here.
2 times b square minus 4ac, isn't it? So
Minus 2bd minus 2bd, Joe. Minus 2bd. Y naught is minus 2bd.
yeah, minus 2bd minus 4ae divided by 2b square minus 4ac, isn't it?
Okay.
So okay, so then this two equation of 2ax will become 2ax will become capital B or uppercase A B. 2ax will become uppercase B, uppercase B, isn't it? So that is actually 2ax will become negative of by plus d, isn't it? So here y is actually equal to y0, isn't it? So we can just put the values there. So 2ax will become negative b into 2bd minus negative of negative b. Okay, okay, negative of negative b, that will become positive. So b, oh, negative b into that will be 2 bds. Okay, so it will be 2 bd square. Okay.
Joe, can you share the
Yeah,
board?
yeah, I'll share the board. I'll share the board. 1 second.
Okay, that will be because I don't have any idea what you're writing there.
Okay. Can you see? Am I sharing?
Okay, I can see myself. So this is your Telegram,
Yeah.
which have FML Brotherhood. Okay,
Okay. So what I did was, okay, at y is equal to
just
y0.
zoom the page, Joe.
Okay, I will make it
Just
big.
to
Okay.
okay, I know you can see. Also use the whiting.
Whiting. Okay, I'll use the whiting. 1 second. I'll just delete this.
Why are
And
deleting this thing?
yeah, I will just start from the beginning. Okay, so
Okay, no, no,
we
no,
know.
no, no need to start from the beginning. Joe,
Yeah,
just undo it. I got it, Joe, undo it.
yeah, no, let's start. I need for my my own
Okay, okay,
satisfaction.
okay, okay, okay.
So x is equal to negative b plus or negative b plus or minus
Minus,
delta x of y, isn't it?
okay.
And at
Over to 2ax equals
yeah,
2ax
yeah,
equals.
yeah, 2ax. We can write 2ax equals, isn't it? And we can say at y is equal to y naught, let y naught, which was actually equal to negative 2bd. Oh no, what was the question? 2bd minus negative of 2bd minus 4ae plus 4ae, isn't it? 4a divided by 2 times b square minus 4ac. Mhm.
Hmm.
Let x is equal to x naught. Okay.
Also, Joe, delete that box. My face from that. Remove
Formula.
my face from your box.
Okay.
Okay, okay.
Now what we can do here is let x is equal to x naught. Okay. So then we can say delta x of y is actually equal to 0, isn't it? So you will get
Delta x of
2a
y naught equals 0.
y not equal to 0. Yeah, y not equal to 0. Okay, so 2a x naught should be equal to negative b, isn't it? And we know that b is actually equal to b y plus d, isn't it?
Yes.
Okay, that is actually equal to
By
here.
naught plus d.
Yeah, here it will become by naught plus d. So, yeah, y naught plus d. Okay, so you will get 2ax0 should be equal to b, there is a negative, negative b into, okay, b y naught I can write it as, what is y naught? I can just put in the
Okay, just
values.
write y naught. We know y naught.
Okay,
Okay,
plus
okay.
4a divided by 2b square minus 4ac, isn't it?
Okay.
So, minus
D.
d. Okay, this negative and negative, it can become positive, isn't it? So this will be 2bd square plus 4ae into d.
Joe,
Yeah.
minus 2bd minus 4.
Oh, yeah,
2bd,
yeah.
the
Hmm?
negative will not become cancelled
No,
because at the top, at the beginning. No, no, no,
yeah,
no.
there's a,
At the second line,
uh,
the inside the bracket, it is a negative term.
oh, it's a
Okay.
negative.
2bd
B
minus 4a.
4a. Okay,
So,
so this will become, okay, when you multiply it with
okay,
d,
there is
so there's a
b
negative
b
here,
here, b here, b times.
negative, no, negative b, isn't it?
Okay, okay.
Okay, so this will become 2bd square minus 4abe divided by 2b square, 2 times b square minus 4ac minus d. That is 2ax0.
So x naught will be.
V equal to, yeah,
Okay, you
2,
essentially found the x naught. Okay.
yeah, yeah,
So we have got x naught and y naught.
yes.
But there is a you have found x naught and y naught, but there is a, but you have to still reason that this x naught and y naught is are the point of intersection of crossing line.
Oh, yeah.
Okay, you have actually found the solution, and
Mm.
since you know that the same point is the point of intersection of the crossing line is because that I have told you.
Oh,
So
yeah.
you haven't actually okay, you have,
Yeah.
in order to show that this x naught and y naught are actually the point of intersection, you have to solve those line equation of those.
Yeah. So
Okay,
yeah,
those
these
two lines.
equations.
Okay, let's. This is very interesting idea. Let's just solve those lines, Joe.
2ax is equal to L1y plus M1, isn't it?
I'll start sharing my board. Okay, you also write. You also write. Okay, let's solve the system. Let's first find y not here. Y here. Okay,
Okay.
solving the system. Okay, right. So
Oh,
let's
if both.
subtract one from the other. Okay,
Okay, equation 1. Okay.
subtracting one equation from other, we get 0 equals y times L1 minus L2, right, plus M1 minus M2, isn't it?
Yes.
Okay, so y becomes minus M1 minus M2 by L1 minus L2.
Okay.
Okay. Okay.
Yeah.
What is M1 minus M2?
1 second. Yeah. So yeah, got it.
M1
So
equals. So what's M1?
1 second. Let me just write this. This will be equal to. So we can say. Yeah. So this will become L2 L1 minus L1 minus L2 times y should be equal to negative of M2 plus M1. Okay,
Okay,
so
I'll
y
just
will
subtract it. I'm not just okay. M1 minus M2, right?
negative
So M1 minus M2 becomes, I think it becomes mm, becomes 2BD minus 4AE over B square minus 4AC, I think. What is
okay.
M1 minus M2? M1 minus M2. Subtract
It's
multiply
it's it's not
2BD.
M1 minus M2. Negative. 1 second. Could you move up a little bit?
This,
Yeah, yeah. Okay, okay, okay. Correct, correct.
okay, there is a negative outside.
Okay.
M1 minus M2 becomes 2BD minus 4AE times square root of B squared minus 4AC.
Minus 4. Yes.
And what's L1 minus L2? L1 minus L2 becomes 2 times B square minus 4AC, I think.
Yes.
2 times square root of B square minus 4AC. So what is minus? So y becomes minus this term 2BD minus
For
4AE.
E divided by 2 times B square minus 4AC.
No, divided by B square minus 4AC
4AC.
whole
Okay.
divided by 2 times
With
square
B
root of
square root of B square minus 4AC.
4AC
And
by 1. Okay.
fine.
So when we uh, make it,
Yeah.
usually make it properly, we get minus 2BD minus 4AE over 2
2
times
B square minus 4AC.
B square minus 4AC. Okay, this is the y, point of intersection,
Yes.
y coordinate of the point of intersection.
Okay.
Okay, and if we
Okay.
move upwards and look at the value of y naught here, this is the same number.
Yeah.
That is how we know that it intersects at
Yeah.
a y naught.
Okay.
Okay, just solving it. Your idea is also correct, but
Yeah, it's
uh,
more, I just jumped
you just found the
onto,
solution.
yeah. I
Okay,
don't,
Okay.
Yeah, that's a problem of I'm a little bit intuitive in that way.
Okay. Okay. You just, this is actually y naught. And for when y is equal to y naught, you can similarly find the value of x no x by substituting the value of y in any one of those equations. This equation.
Okay.
Okay. So we get 2ax. The substituting y equals y naught into 2ax equals L1 y naught. Y naught minus or what's plus, I think it's plus m1. So we get x equals L1 over 2a times y naught plus m1. If we solve this,
Yeah.
we get
I found the reasoning for why we can just start from why not.
okay.
Okay,
Okay,
think
just
about
I will discuss it, but just okay.
yeah,
Just let me write it. Name it as
yeah.
okay. Name this
Just X no
as x naught. Okay, that is the crossing line
intersects at
uh, intersects at the point whose y coordinate
yes. Why not?
is y naught exactly. That is the crossing lines will look like this. Will look like this point will be y naught. Okay, this will be the
Yes.
x naught. Okay, Joe, tell me your reasoning.
Okay. So the reason for there are two lines is
Mm,
because we have a quadratic equation,
yes.
isn't it?
Yes.
So the quadratic equation has two roots, and
Okay,
the two
I
roots
will
are
stop share. I will stop sharing my board so that the audience
okay.
can see you correctly. Okay.
Okay.
Okay, Joe.
Okay. So the reason why we are having the two lines crossing each other is because x is a quadratic equation, isn't it?
Yes.
Okay. So mm,
No,
yeah.
only that
Because
thing.
no, not only because
Just just
that's
okay. Okay.
yeah, in this case, okay. So here, if x is not a quadratic equation, then there is a single point for x and y, isn't it?
X is not a quadratic equation. There is a single
It's
point.
point of
Okay.
for
Okay. Okay. Okay.
okay, which means that for the value of x, which is if x is a perfect square or
Joe, share your board.
okay, yeah, better. It's like an intuitive reasoning, okay.
Okay. Okay.
So
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 discuss
we
that.
wrote x is equal to negative b plus or minus delta x y, okay, divided
Yes.
by the
Use a
2
white color board.
uh, okay, I will use white color. uh, okay,
Okay. Okay.
all right. B square minus 4ac, okay, this is the delta x, okay, I can use it delta xy, okay, is equal to 0. Okay, now this my okay, this will lead to something negative b plus or minus some value divided by 2a plus or minus plus some value, isn't
Yes.
it?
Yes.
Essentially what is going, isn't it? Equal to negative b by 2a, okay,
Plus or minus.
plus no, minus some value, isn't it?
Yes.
Delta
Yes.
xy, okay. Now we can say that at delta xy is equal to 0, this is line 1 and this is line 2,
And that is
okay.
actually that would not be correct, Joe, because the delta xy is a quadratic term.
Yeah, let me just say this root of this is okay divided by 2a,
Okay,
okay.
if we take the quadratic term, that square must vanish, and we should get a
Yeah,
linear term.
Yes, that's what I'm saying. At y is equal to y naught, the square term delta xy vanishes, isn't it?
No. Delta x no. Yes, exactly. It vanishes.
Okay, so then these x's become same, which means that they are their solution. We found the solution.
Yeah, that's what we have been writing.
Yeah. No, instead of so I told you why I found the reason why we can start from y naught.
Um, Joe, okay, let me explain this thing. Okay,
No, did you understand this?
I got your point. I got your point. Okay, okay. Look at what we have been doing here essentially.
Oh, okay.
Okay, this was our delta x of y.
Yeah.
Okay, okay. This was our delta x of y equal to 0. We made it equal to 0. That
Mm.
because we know that in this case it becomes 0. In this case it becomes 0.
Mm.
Okay,
Okay.
it becomes 0 and we named that point y naught. It was just
Okay.
an arbitrary. We assume okay for a y naught it becomes 0.
Yeah.
Okay, and since it becomes 0, we know that this discriminant must vanish.
Yes.
Okay, and we took advantage of that vanishing equation so that we can manipulate our this thing. Okay,
Okay. Okay.
okay, and we from that equation we made it this thing as a perfect square, not vanishing here, this perfect square. We haven't substituted y equals y naught here.
No. So
Okay,
yeah,
you want to remember that the crossing lines are not a single point. It extends throughout the xy coordinate system. So it has values over all y and all x.
yeah. So but the solution is the crossing point where the value should be crossing. That's what we will need to find, isn't it?
Solution solution of
No.
what? Solution of not this equation. Solution
No.
of the solution of these equations.
Yeah, that's what we need to find. So when we are as I explained, as I understand, we need to find. Okay, we found that it will be two straight lines,
Straight lines.
isn't it?
Okay.
Okay,
Though and
they
the
must.
solution of that straight line is the point of intersection.
Yeah, these straight lines must meet at some point of intersection, isn't
Yes.
it?
Yes.
So the and so now
The
what
solution of that conic equation we should not be a point
no,
because it should always
it's
be a
a
curve.
straight.
That's algebraic geometry.
Yeah,
That it should be a curve
it's a,
or a
so
line.
yeah, we have two crossing lines, but we don't know where they cross. That's
Cross.
the uh, okay.
Okay.
So what we did was we have a quadratic equation which is equal to x is equal to negative b plus or minus delta xy, isn't it?
Okay. Yes.
Delta x divided by 2a. At
Okay.
delta xy, both so since we had both positive root and negative root,
Okay.
to say we had two lines.
Okay. Yes.
Essentially,
That's
okay,
correct. That's correct.
when delta xy is equal to 0, both the x's will become the same, isn't it?
When that happens, when y equals y naught,
Yeah, that happens when y is equal to y naught. So we can
for
essentially
no other
present.
value of y, we can assert that condition.
Yes. So what I'm doing is that what I'm saying is that we can essentially start from there. So at y is equal to y naught, both x1 and x2 are same, which is the point of intersection.
X naught,
So
X naught.
x naught. Okay, x
Yes.
naught,
That's correct. That's
x
correct.
naught. So then from so we already found y naught.
Okay.
Okay,
Yes.
we already found y naught,
And
so
X
we
naught.
can here from the simple reasoning we found x naught also.
X naught. That's absolutely correct. But we haven't shown that the conic section is a pair of straight
Uh,
lines.
yeah, no. So after this, showing that the corner section is a pair of straight line, we can find the point of intersection directly from this method or this reasoning.
That is correct. But
Yeah.
you again we haven't. There is no reasoning connecting that solution to the point of intersection of the pair of straight lines.
That's what I said.
No, pair of straight. In order to find the point of intersection of pair of straight lines, you have to solve the pair of straight lines. That is how you
Yeah.
can connect that idea with this pair, this
No,
equation.
essentially, listen. Essentially, when we are solving a pair of straight lines, we can say we are, so both the x coordinates and y coordinates will be the same. That's the same thing,
Yes.
isn't it? Okay.
Okay.
So, which means that if 2x equal to L1 y1 plus m1, okay, plus m1
Okay.
should also be equal to 2 L2y plus m2, isn't it? At the point of intersection.
Yes, 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 yes.
Isn't that
This
is
is
was
what you're.
essentially, yeah, essentially saying.
Maybe we are on the same page, but I am not
Fine.
following your exact
Yeah.
reasoning. Maybe we are on the same page, but what you said is correct about finding the solutions. Finding solutions is what you said is absolutely correct. But you have, but my reasoning is that in order to find the point of intersection of the pair of straight lines and show that it is y naught, you have to just solve the pair of straight lines.
Oh, yeah, that's yeah,
That is
yeah,
geometrically we can arrive at that
yeah,
idea.
yes,
Okay, you
yeah,
can
but
arrive at the solution where you can find the value of x naught using y naught by directly substituting y naught and making it equal to 0, delta x y equal to 0, and finding the
yeah,
x naught. That is absolutely correct.
yeah.
But
So
okay,
yeah,
Joe.
that's what I was saying. So okay, let's go for here today. I will explain.
Okay, okay.
I'll think about.
Maybe you are, but I am. You are absolutely correct about finding solutions. But what I'm saying is that the pair of straight lines. First of all, you have to show that the conic section is a pair of straight lines.
Yeah, that's what I said. Yeah, yeah. First, I agree with you on that. But on the part, second part, I think instead of solving in this way, we can use the
Instead of
reasoning.
you said instead of solving the pair of straight line to find the solution. Is
Yeah,
that what you said? Instead of
no, solving the pair of straight lines
to
essentially instead of solving these steps, not solving the pair of straight lines, essentially instead of solving these steps, we can use the reasoning there,
but
isn't it?
how can we deduce the conic is a pair of straight line?
No, once you establish that it is a pair of straight lines,
Oh, okay, okay. That is once you have arrived at this
uh,
system, then
then
instead of
from
solving this
in way
steps,
we can
we
just
can just substitute x and y naught and find.
oh,
That is absolutely correct. That is absolutely correct. Okay, but what I
okay,
have shown is that the pair of straight line intersect at the y naught by just solving the pair of straight line.
okay.
Okay, but for showing that conic itself is a pair of straight line, you would have to do all these steps. There is no
Yeah,
way
yeah,
of
yeah.
cutting the edge,
Yeah.
cutting the corner here. Okay, because you
Okay.
have to arrive at these equations in order to show that this is you have to arrive at these equations, and these equations cannot be arrived by just plugging the numbers. You have to algebraically manipulate and form
Solve it.
convert that equation into this form. Convert, not solving, converting that equation into this form.
Okay.
Okay, that's what I have shown here. And okay, you are absolutely correct about solving that equation. You just can just plug in values for a y naught, and you can find x naught. Okay, again, Joe, it I think we have passed. It's 1 hour and 39 minutes. I think it's our longest lecture here. Let's
Yeah.
stop here today. Okay, Joe.
Okay.
We in the next class we are concluding with the classification of conic sections here, because we
Yes.
have looked at all cases, isn't it?
Okay.
Okay,
Yes.
we have looked at the first case where b square minus 4ac is equal to 0. We have shown that it's a parabola. We have then looked at the case in which the b square minus 4ac is less than 0. We have shown that there no conic section can be formed, and a point can be formed, and also an ellipse can be formed.
Yes.
Then we have looked at the case b square minus 4 is greater than 0, where a hyperbola along the x-axis can be formed here, a hyperbola along y-axis can be formed here, and a pair of straight line can also be formed. Okay, that is how we can classify these conic sections algebraically. So we can conclude our discussion here. But let me just, I'm taking 1 minute to express another important thing. If we look at our original equation, ax squared plus bxy plus
cy squared plus plus dx plus ey plus h.
Plus h. Okay, we have made this equation into an equation in x. Okay.
Yes.
What if we made this equation into an equation in y?
We would
That
have
is
the
cy squared plus bx plus e, right? Y plus ax squared plus bx plus h equals 0.
Yes.
And we can find y as minus b, where this is b.
Okay.
This is a.
Okay.
Plus or minus square root of delta
y
of x over a.
to
a. Then this entire reasoning still holds.
Yes.
But instead of y delta xy, we get x delta y. And the point of here, y naught will become the x naught.
Yeah.
Okay, entire thing reverses. That has actually consequences, but we are not digging deeper into this. Maybe we'll do another series on that. Has really interesting consequences, especially finding area of an ellipse, especially finding the range axis, which is a new kind of axis for ellipse, not semi-major and semi-minor axis. We can find those axes. This is very interesting idea, but we are not we are sticking with our curriculum on algebraic geometry.
Okay.
Not dwelling too much into conic sections only. Okay. But remember, this classification has algebraic consequences.
Okay.
Okay. So at that point, let me conclude our discussion. I have to thank you, Joe, for sitting without sleeping. Okay. Okay. In the next class, we will dig much deeper into algebraic geometry. We will discuss one of the most important concepts in algebraic geometry, affine transformation.
Okay.
Very, very important. It's at the core of affine geometry. We will then we will look at projective geometry. Whatever you want to study, you tell me. We can discuss. Okay, it's all right.
Okay.
Okay, Joe. Okay, bye. I'm stopping our recording.